I'm with Vogue. Today we're going to do 20 questions with Angela Bono.
Oh, come on in then.
Today's topic, projectile motion. Why don't you show us around?
This is the staircase. The wood is imported from Portugal.
So tell me, what exactly is projectile motion?
Projectile motion is when an object is only being acted upon by gravity.
Want to show me around a little more?
Alright.
Oh, who's that?
This is my alligator. His name is Buster.
Okay, well, nice. And who's this?
This is my maid.
So, back to projectile motion. It's a bit of a confusing topic. Would you mind expanding more on it?
Well, sure. When thinking about projectile motion, you need to look at the object in its two separate dimensions, the x direction and y direction.
So, next question. What would be an example of an object in projectile motion?
This!
Angelo was later arrested for assaulting the cameraman. Turns out that wasn't even his house, and he murdered the family who previously lived there and illegally stayed in the house. However, Angelo was heading in the right direction while talking about projectile motion. Despite Angelo not being able to answer any of the questions, Vogue has decided to be professional and continue explaining projectile motion.
Let's take a look at an example. A frog leaps at a 30-degree angle from the horizontal. It's in the air for 0.68 seconds. Find the frog's initial velocity and how far it jumped. So let's break this down into the x direction and the y direction. In the x direction, the time elapsed is 0.68 seconds. The acceleration in the x direction for all projectile motions is always 0. Now we're trying to find the initial velocity in the x direction. Now let's take a look at it in the y direction. The time elapsed is also 0.68 seconds. The acceleration for all projectile motion problems in the y direction is always equal to gravity, which is negative 9.81 meters per second squared. The change in y will be 0 meters, as the frog will come back to the ground. Now, we are trying to find its initial velocity in the y direction as well. So, based on what we have here, we can see that we can use the variables found in the y direction to solve for the initial velocity. We can do this using kinematic equations. The one that we can use is y is equal to y initial plus initial velocity in the y direction times time plus 1/2 times acceleration times squared. So, the change in y is 0. We are trying to find initial velocity in the y direction. Time is 0.68 seconds plus 1/2 times negative 9.81 meters per second squared times 0.68 seconds squared. If you solve this and plug into your calculator, the initial velocity in the y direction is equal to 3.34 meters per second. Using this, we can figure out the overall initial velocity and the initial velocity in the x direction. How can we do this? By using trig. So, we know the angle that the frog jumped at is 30 degrees. And the initial velocity in the y direction is 3.34 meters per second. This is the overall velocity, and this is initial velocity in the x direction. So, to find initial velocity, we can use trig. Sine of 30 degrees is equal to 3.34 meters per second over initial velocity. Initial velocity is equal to 6.68 meters per second. we can also find initial velocity in the x direction. Cosine of 30 degrees is equal to initial velocity in the x direction over 6.68 meters per second. Initial velocity in the x direction is equal to 5.79 meters per second. To find the distance traveled in the x direction, as the question asked for, we can multiply its velocity, 5.79 meters per second, times the time elapsed during the jump, which is 0.68 seconds. The change in x is equal to 3.93 meters.
Overall, projectile motion is when an object moves along a curved path in 2 dimensions and is under the influence of gravity and only gravity. By looking at an object in projectile motion in its x direction and y direction separately, one can use basic algebra and kinematic equations to find values such as distance traveled and initial velocity.